Welcome to Introductory Biology. This is the first of several lectures on, go figure, biology. Today's lecture is on the responsibilities of the scientist. But before we can get into responsibilities of the scientist, we're going to need to figure out what is a scientist, and more importantly, what is science. So there it is, the question out to you: what is science?
So you said it's what is science? Science is a study of the world. Is that what you said? In the observations we make about the world, you look around you and you see stuff, and thus that is science. Being minimally observant about what's going on around you. Anybody else have a different definition? Different way of looking at science? I'm good to go with that if you want to use that definition. But it's fluid. Language is imperfect. Language is describing a process here. Typically, most people are going to look at science as something that's verifiable, retestable. It's verifiable, it's retestable. They're going to be, you're going to not only look around you and see what's going on, you're going to test your assumptions. You guys have tested things your whole life. Next class, we're going to get into what's called the scientific method. You're going to observe the world, identify things going on around you. You'll notice stuff happens. The sun goes up, the sun comes down. You can put forward a reasonable explanation as to why that happens. I don't know, a giant ant carries it across the sky. And you can test that. Ultimately, science is testable. If you remember nothing else, science is testable. Now, science has this sort of evil twin brother. It's that evil twin brother with the goatee, thus it's evil, called pseudoscience. And it's unfortunate. It's terribly unfortunate, but pseudoscience is getting almost as much attention these days as science. Here you're going to use vague or exaggerated or untestable claims. You have an over-reliance on confirmation rather than refutation. You're going to say, I don't know, I put Jell-O on my head and my headache was cured, thus putting Jell-O on your head cures headaches. There's a lack of openness to testing by other experts. There was a psychic by the name of Uri Geller a long time ago, and he would bend spoons back and forth. And it amazed people. He's a psychic magician. And he was doing his spoon bending bit, and scientists said, "You're bending these spoons." He's like, "Yes, I'm doing it with my mind." And they're like, "Come into our lab. We want to measure this." He's like, "Oh, I can't go into and do it in your lab. It only works here, right now, when you watch me. Can't measure it." I don't know if you guys, have you ever seen the History Channel? There's a show on there, Ancient Aliens. If you're up in the middle of the night at any time, Ancient Aliens will be on, and it is the weirdest stuff you're going to see. There was a particular episode where they had come up with a brand new way of having infinite amounts of power. Because if you built a pyramid, that's the pyramid of my fingers, just right, made it out of copper, it would float up and start spinning around all by itself. Yeah, I know, right? So this happened in the lab, and they recorded it in the lab, and everyone's like, "Whoa, aliens!" So other experts said, "Hey, we want to do that in our lab." And they said, "Oh, you can't. It's unfortunate, but you see, the way the ley lines intersect, it only works right here." Lack of openness to testing. An absence of progress. Have you guys ever heard of, what's it called? Astrology. Have you heard of astrology before? What is astrology? Yeah, but more than just planets and stars, because that's astronomy. What? It's their effect on us. Horoscopes. You guys all know what your sign is, right? Yeah, I assume you do because you've read the paper at some point. Like, is it Stephanie? What's your name? Samantha, sorry. They're S words that are about the same length. Samantha, Sam, sorry. What's your sign? It's Capricorn. What's your name? Yeah. Joseph, what's your sign? Taurus. Is there anybody here who doesn't know their sign? When were you born? Okay, what month? August? Anybody else born in August? He's Leo, thanks. There you go, now you know. In case you ever wanted to read a paper and be like, what's my day going to hold? We all know these things. Do you believe that the stars have an effect on your life? Some of you might, some of you don't. But the big thing is, and why this is not science, is it hasn't changed since the time of Ptolemy, 2,500 years ago. Everything's been the same. They used to map out the planets, figure out exactly how bad of a day you were having that day, and then write it all down. Don't do that anymore. So it's gone from being what was a science into a pseudoscience. Personalization of the issues. Oh, geez, we see that all the time now, don't we? People don't just attack the subject matter, they attack the person. There was something recently, Bill Nye the Science Guy. Do you know this guy? Okay, so Bill Nye, he disagreed with somebody. And he said, here's all the reasons I disagree with you. And that person turned to him and said, well, you only have a bachelor's degree, so I don't care. It was attacking the person, not attacking the argument. In science, you look at the arguments, not the person who produced the argument. Otherwise, you're veering into pseudoscience. Questions so far? Science, testable. Pseudoscience, not testable. You can't test it. Just the way it is. Let's say, one pseudoscience I was just reading recently. You guys heard about this whole thing about flat Earth? Yeah, I know. And everyone's like, what is wrong with these people? We solved this one a long time ago. They're saying what they're putting forth are untestable claims. So this idea that, was there a cover-up of the moon landing, for instance? Well, everything's covered up. We can't test that there was a cover-up. We can't test everything that they point out about why the Earth is supposed to be flat is untestable because it's all a big conspiracy and everything's being hidden. Once they allow for testing, then it might become more scientific. I guess the closest thing there was testing. Did you see recently there was a guy who created his own rocket? Did you hear about this? Okay, so I was going to say insane. Let me put it this way: amateur scientist decided the Earth was flat, and he was going to test his hypothesis, and he was going to test it by literally building a rocket that he was going to launch into a very near orbit to see if the Earth was actually curved. In his backyard, he built a rocket. Now, this is not like, it's not something you should attempt on your own. I believe this one was powered by, what was this powered by? It was partially powered by dynamite. I mean, it's not, this is Wile E. Coyote-esque. And he was set to launch it, and then the government came in, which tried to give him credence to his claim. The government came and was like, we're not going to let you fire off this massive explosive with you strapped to the top of it. And then he said, well, the government stopped me, thus they're covering it up. He was so close to testing it and making it science, and then he slipped back into pseudoscience. Here are some of my favorite pseudosciences. These are honest to goodness real. Cancer can be cured. All you have to do is buy this book and you can find out how. That's kind of exaggerated. Scientific tests prove that Lucky Strike is milder than any other brand. Well, it says scientific tests, thus it must be science. Again, an exaggerated claim. And by far my favorite, honest to goodness, true lecture at a college. James Capers, Methods and Practices of Psychic Defense from Hostile Invaders from Another Planet. Real class. People paid to go to this class. Now, I'm saying it's pseudoscience. But how could it be science? How could this Methods and Practices of Psychic Defense from Hostile Invaders from Another Planet be science? What do you need? You need you need an alien in the room with you. Then what do? Ward them off with your mind. You try different defenses. You might have one person who's not trying to defend, one who is, and see whose brain melts first. Whatever. But there you have a test, because science is testable. Till then, pseudoscience. Now, good science can fall into pseudoscience. Good science can sort of devolve. Mark Twain said, and this is one of my favorite quotes, in case you guys know Mark Twain, right? If you haven't, you got to read Mark Twain. The man was brilliant. It's easier to fool people than convince them that they have been fooled. And I wrote this lecture, I want to say 6 years ago, and this is getting more and more true. An idea will become pseudoscientific when it can't be separated out from the ideology. You all know people. I guarantee you know people who you disagree with. You probably had friends in high school or friends in middle school who you still correspond with on like social media, and they post the nuttiest things you've ever seen in your life. Am I mistaken in this? You've all got those insane relatives. I have a crazy uncle. Okay, let's put it this way. You guys went to Thanksgiving, I assume, or had Thanksgiving maybe with family and friends. There was that one person there who you vehemently disagreed with, right? You just don't get how they think. That's my Uncle Larry. My Uncle Larry is a horrible human being. And I say this with all, and not love, I don't even like the guy. I'm related to him, but I'm related to other organisms too. He is sexist, he is racist, he doesn't like any change of anything. The world should be like it was back when he was a kid, because apparently that's the way everything should be. This guy has a very skewed perspective in my mind. He sees no use for immigrants, at which point I turned to him and was like, well, literally, your mom was an immigrant. He's like, yeah, but she was legal at the time. It's like, no, she really wasn't. I know this story. I'm part of the family, remember? She came over illegally. It's like, yeah, but then she became legal. And I was like, no, she didn't. She died. Now she's legally buried. There are some major problems. I used to feel, back in the day when I had hope, before I became cynical, like the rest of you guys, that maybe through argument I could change his mind. Maybe by reasoning with him I could change his mind. Now, you guys have done this at some point in your life too, haven't you? You thought, they just need a little bit more information because obviously there's something missing from them. Turns out, no matter how hard you argue with someone, their first impression is the impression that they're going to hold on to. That's what it's called, their meaning perspective. That is what they will cling to for dear life. It's easier to fool somebody, to tell them first. You know, you get somebody first, you introduce new information, that person then believes that information. After that, it's hard to convince them that they are wrong. You guys hold some strongly held beliefs, I assume. Imagine if somebody came to you and said, through reason, I will convince you that you're wrong. It's going to be up to a scientist to force themselves as much as possible to be open-minded, to look at those different possibilities and incorporate it into a new worldview. Most people can't do that. And honest to goodness, it is getting harder and harder and harder as things become more and more polarized. I guess the point of that is, if you're going to try and convince somebody of something, be sure you're the first person to talk to them. So here we have the scientist. That character who goes out and tries to make sense of the world, tries to observe the world and test it. The scientist is inquisitive. What does it mean to be inquisitive? It's kind of, questioning. And in the future, you don't need to raise your hand. Just start shouting things out. It's cool. If you feel like heckling, go for that too. Ask questions about the world. See what's going on. Explorative. Go figure, that means they explore. They look at the world around them. They're persistent. They keep going, and they're going to need that. You guys, a lot of people have a mistaken belief that scientists run experiments, and those experiments work. And they usually don't. The vast 97% of the time, when I'm making up statistics, most of the time, the vast, vast, vast majority of the time, if you run an experiment, it will fail dramatically the first time, the second, the third, and up to the 10th. And then you start learning from your mistakes. You have to be persistent for that to happen. The scientist is creative in the most literal sense. They create new ideas. They create new things. They take two ideas that seem very far apart and put them together to build something new. And they're analytical. They can look at concepts separately, analyze them, think about them, and come to an unbiased conclusion about what those two different topics mean together. So that's the scientist. Those are the characteristics of the scientist. Now, you would think with those characteristics, the scientist would be very trusted. People would look at a scientist and think, that person might know what they're talking about. But it turns out, in a survey of the most trusted professions out there, people actually trust paramedics more than anybody else. And that kind of makes sense. You got to give them credit. Paramedics, they're coming to your house, they're saving your life. You don't trust them, you die. It's just, there's a vested interest in trusting paramedics. Same with firefighters. I mean, these are people who come to your house carrying an axe, and you're like, come on in. Rescue volunteers, which apparently is now all one word. Nurses, because you got to trust them to give you medical treatment or you die. Pilots, trust them, I guess, because they're flying a plane, which is sort of magic that it stays in the air. I mean, think about it. Giant, multi-ton piece of metal hurtling through the air. And you're like, I'm going to get on that. I'm going to go somewhere. And it's going to be fast because of that guy keeping me safe. Doctors, again, medical profession. I love, though, people trust nurses more than they trust doctors. Doctor walks into the room and says, I'm sorry, you're dying. And the person says, you know, that's nice you think that, but I'd like the nurse's opinion. Pharmacists. This one does also make sense. You guys have been sick before. Have you gone to a pharmacy? At the very least, have you taken any medicine? Everybody's taken some medicine at some point, right? Did you ever think about this? And once you think about this once, it's going to stick in your head forever. Pharmacist's job, part of a pharmacist's job is to make sure that you get the right medicine. What if they screw up? Little white pills all look the same, don't they? You have a hard enough time figuring out what's your allergy pill and what's your birth control pill. I mean, and what's a Tic Tac? I mean, there's all sorts of things that can get thrown off if you get the wrong medicine. Yet, we absolutely trust the pharmacist to get it right every single time. Have you ever met pharmacists or people who work in a pharmacy? Have you met them when they're outside of the pharmacy? If you met them when they're outside of the pharmacy, you might think about it and think, you know, maybe I shouldn't go to that pharmacy anymore. Veterinarians. We still haven't hit scientists, by the way, because really important to take care of your dog and cat. Armed forces personnel. Farmers. Okay, now I'm starting to get a little upset. Police. And then scientists. So what this is saying is people trust the police more than they trust scientists. They trust farmers more. Okay, so you got a scientist, you got a farmer, and you're like, all right, so can you explain to me what's going on with climate change? Let me ask the farmer first. That's an issue. Scientists used to be the most trusted profession. Oh, by the way, next is after scientists, teachers, dentists, and childcare workers. I want to point that out real quick. People care more about trust their veterinarian more than they trust childcare workers. Yet they are perfectly willing to be like, but take my kids. I think that's hilarious. Because if you have kids, you're like, yup, got to get them out of the house somehow. Scientists used to be the #1 trusted profession. But because of the influence of pseudoscience, because of some bad apples, the entire profession has lost face, and it's dropped farther and farther and farther and farther down. And now, a good half the country doesn't believe the things scientists say. They think there's this massive conspiracy. Back to flat Earth, right? Scientists, the government, everybody's in it together to convince us we're wrong. Fun story, least trusted professions, shouldn't come as a surprise. Politicians, #1. Lawyers, #2. Professional athletes, #3. Now, I have just revealed to you all of this information. What is it that you should have asked me right away? Yes? That's the exact right answer. You're going to go far in science. That's, you don't believe it? Don't worry, I got it from...
Because it changes like every single time. Because, like you said, bad scientists are just one bad incident makes a whole group of people not trustworthy go down. So it matters even what is taken out.
So, yeah, what's your field of study going to be? Psychology? Yeah. If you want to go into a real science, too, it would come into biology or chemistry or physics because you've got a good mind. That's very analytical. Very well done. Yeah. No, that was a compliment. I'm sorry. I wasn't like... Yeah, no. Psychology's still better than sociology, so you're good. No problem. The big thing is, and she's absolutely right, where did this come from? It came from Reader's Digest. I was literally sitting there one day reading Reader's Digest in the only place anybody ever reads Reader's Digest. And I found this and I pulled it out. I've got to show it to you. Now, do you trust Reader's Digest as a good source? No. They surveyed 100 people. Maybe 80 of them were paramedics. You don't know. We don't know what's going on. So always find out where the data is coming from. Always look back to the original source and see if you can trust that original source. So I'll tell you from, again, this particular lecture is drawn from some weird sources and directly from my head. But for the most part, I will absolutely tell you if you want to know where the information came from. More often than not, it's a peer-reviewed book or a peer-reviewed paper. Now, the scientist has several responsibilities. They need to accurately record their results, not introduce their own personal biases, effectively communicate their findings, and take responsibility for their research, which can also be rephrased as don't be evil. Yeah, don't be evil. That's an important thing here. Don't worry, I'm going to go through each of these on their own. First off, you need to accurately record your results. You don't write down what you think you should have gotten. You write down what you actually saw. This is going to be important for you in lab, too. This semester, I'm not teaching Bio 101 labs. When I do teach Bio 101 labs, I am far more concerned with you analyzing the thing you actually saw than you telling me, here's what I think should have happened, or here's what happened, or making something up. An example of this is in 1928. There's a scientist who was studying fungal growth. No, he wasn't studying fungal growth. He had just plated bacteria. This is right before the holidays, right before Christmas. He leaves this Petri plate on his table. He walks away. Comes back 3 weeks later. Now, what he was analyzing was the growth of that bacteria. When he came back, what he found was there's contamination. Somehow, over that 2-week period, he had gotten fungus to grow on it. Now, he screwed up. This was contamination. This was a waste of resources. And he blew several weeks of research because of it. So if you think about it, you take somebody's salary, you divide it out into weeks. He blew all of that money. So he had an option. He had some choices to make. One, he could have just sort of pushed it into the trash, pretended it never happened. Two, he could have looked at it and said, yeah, there's fungus there, but I can kind of see what would have happened. That's what you're going to be most tempted to do. Yeah, it's off, but I can kind of get an idea, so I'll just write down what I think it actually happened. Third thing he could have done, and what he did do, was he had to report it to his boss, write it down in his lab notebook, and say what actually happened. Well, he got reprimanded for it, but what they ended up finding was that wherever the fungus was touching the bacteria, there was no growth of bacteria. This led to the first development of antibiotics, which have gone on to save countless lives. But probably even more important to you guys was this guy, Spencer Silver. Spencer Silver was a chemist working in 3M labs. 3M, think sticky stuff. They made super glue. Have you guys ever worked with super glue before? Anybody used super glue? Okay, you use super glue, what do? What happens to your fingers? Every stupid time. That's right, they're glued together. And then you look at them and you have to figure out a way to unglue them together. And the way we all end up ungluing it, even though we could use some sort of chemical to unglue it, is we just sort of rip. You get some skin on one side, skin on the other. It's not very nice, but it gets it undone. They were trying to create a glue that was stronger than super glue. Yeah, I don't know, for a dentured fixative or something like that. But they needed a very, very strong glue. So Spencer Silver was working on it. And he took this several months' worth of work. It was an organic distillation, so it took a long time. And he took it. He took one side, painted this with glue, put them together, and then he went to rip them apart, and he was hoping that, they wouldn't budge, but one came off entirely. And on this side, it still had all the glue, and over here there's no glue. So he went to his boss and said, look, I haven't been able to figure out how to make this very sticky, stronger glue. I don't have the new super glue. But this is what I did. I made this stuff that only sticks to one side of the paper. Life's good. Boss fired him. That's not what he was there for. His research and development wasn't working. Got rid of him. Well, the boss then had to present to the board that had on it their marketing people. Now, how many of you guys are in business? Business administration. Okay, so this is where you come into the story. They looked at this not as a failure, but as an opportunity. This is something that could be marketed. So that's where we ended up discovering Post-it notes from somebody's mistake. And it's gone on to make millions upon likely billions of dollars. Spencer Silver was on the patent for it, which means every time you use a Post-it note, he gets a little bit of money. Isn't that neat? Don't introduce your own personal biases. We all have biases. It's unfortunate. But as a scientist, you need to do your best to set your biases aside. Not let them interfere with your decisions or with your research. It comes back to it's easier to fool someone than convince them they have been fooled. Here I've got examples of sort of two big, for lack of a better word, controversies, two big sides to stories. We've got climate change over here, where you might have climate change is caused by humans versus there is no climate change, or climate change is not caused by humans. On the other side, we've got genetically modified organisms are just as good as organic foods, or genetically modified organisms are inferior to organic foods. These are two things that you guys have opinions on, I assume, right? You weren't living in a box where you have absolutely no opinion on this. At some point in your life, you were exposed to these concepts. Am I mistaken in that? You need to not allow your own personal biases to influence your decision, your analysis. If you're doing a research article on the impact of humans on climate change, and your data shows you something that's contrary to what you believe, you report your data. You don't report your initial thoughts, or you don't let your initial thoughts cloud the data. Same with this idea of GMOs versus organic foods. As you're presented with new information, you need to constantly update your worldview as a scientist. You can't afford to simply hold on to what you believed before. You guys are in college. You're constantly getting new information. You're constantly being exposed to new things. In your psychology class, have you learned, well, I know it's like the second day of school, but have you learned, okay, have you learned anything new that changed the way you viewed the world? Yeah. What did you learn? What's changed the way you saw things?
The way you look at different people.
Do you go around now, with your psychology background, actually like trying to analyze personality types and everything, and you start to view people that way?
Yeah, you also have like sympathy towards people.
Oh, really?
When you learn about like certain disorders and stuff, because then you instead of getting annoyed with them, so I have more patience now.
So a lot of you has changed based on your experiences. You've pulled things in and you've changed yourself, and that's what I'm telling you. You're going to be a good scientist. You change the way you view the world based on your data. You don't expect your data to conform to your view of the world. Does that make sense? It's weird, but I've noticed that in Danville in particular, people have an expectation that the people around them have the exact same beliefs they do. And that is not the case. For instance, I'm going to ask you guys, so we're going to do a quick poll. Let's go with, we'll just talk climate change real quick. So climate change does not exist or is not man-made. And then we got climate change exists and is man-made. So those are the only two categories I'm going to let you guys vote in. One of those two. So if you guys would, close your eyes so you can't see. I know. You're like, that's not right. Which one don't you like? Both of them?
Yeah.
Oh, so there you go. So just close your eyes. Everybody close, because I don't want you guys to be sort of influenced by each other. Put up your hand if you think that climate change does not exist or it is not man-made. Okay? All right? And climate change exists and is man-made. Wow. Okay. Open your eyes. That's actually very unexpected. Usually I have a 50-50 split, but for some reason in this class it was much higher climate change exists and is man-made. That could be a change in culture, or it could just be what's termed small sample size. So if I was to look at this across all the classes, we might see something different. But the interesting part is to note is there are people in here who are just as educated as you, who have a different opinion, even if they've seen the same information you've seen. Different people can draw different conclusions from the same set of data. It doesn't invalidate either one. Next up, effectively communicate your findings. We talked about Bill Nye. The best way that scientists, the primary way scientists convey information to each other, is through publications, the peer review process. We have whole journals associated with specific fields. And it gets really, really specific. Like the Journal of Southern Virginia Geological Aberrations. It's really specific. The way these journals work is a scientist comes up with an idea and tests that idea. They write a paper about it. Usually it's involved, they test some hypothesis, they look at statistics, and then they draw conclusions and put it out there for the world. Their goal is to add to the overall body of knowledge. Now, it doesn't get published right away. What happens when that scientist submits it is the paper is then distributed to 5 or 6 other scientists. The job of those 5 or 6 other scientists is to absolutely destroy that paper, to rip it apart, to find all the holes so that it can be fixed. And then those 5 scientists send the draft back to the original scientist, whose job is to correct all the flaws. So that takes about 3 or 4 months. The scientist then reruns their experiments, rewrites their paper, submits it again. It goes out to 5 different scientists, who then review it, find all the flaws. They send it back. Do you guys ever, you've taken English 111, composition yet? If you've taken composition, anybody take it with Miss Gott? Okay, a few of you guys have. So did she write all over it with a red pen? Yeah. When you turn in an English paper, you're going to get a lot of commentary about it from one person. And then your job is to fix it, learn from your mistakes, turn it back in. Then you get another grade. For scientists, they have to keep fixing it until it's perfect, until it's absolutely right, according to the reviewers. That's when it gets published. And even after that, it's reviewed by everybody, all the other scientists who want to read that journal, who can then write letters to the editors saying, here are the problems with this paper. They've misstated the conclusion, whatever. That's the peer review process, which is why when you're looking for information, peer-reviewed journals are the best place to go. The college has this library over there. You can find peer-reviewed journals on any subject and probably find specific information to back up or refute whatever claim you want to make. That's the best place to go. Another way to get information, to communicate your findings, is through a lecture. Sort of like what I'm doing here. You get up in front of people. Those people may not know as much as you do about a subject, so you tell them about it. Lectures might happen at conferences. Conferences are like lectures, but with an open bar. You might hear about things on television. The media loves to put out new scientific breakthroughs that they have no idea how they work. You got to be kind of careful with what's going on television. Some of it's really good, some of it's really bad. How would you confirm what you saw on television? How would you be able to figure out if what they're saying is true or not? Go to the publications, look at the peer review. And then finally, the internet, which is both awesome and terrifying. You get some really wild things that happen on the internet. Some fantastic memes that pop up, like bananas can cure cancer, or I don't know, the Japanese invented blue strawberries that are genetically modified and will cause you to pee in different colors. There's all sorts of stuff out there that's really weird. The best place to go to confirm or refute what you see on the internet is peer-reviewed journals. And coincidentally enough, they are also available on the internet. You just have to know where to look. A lot of times, Google Scholar is a really good source of information. A bad source of information would be like Wikipedia. Wikipedia can get you going in the right direction, but it's not going to get you all the way there. Anybody can change Wikipedia at any time. I know. Let me tell you a fun story. So I changed Wikipedia one time. I was very excited about it. I assigned my Bio 102 students it was an assignment on, they had to recreate a paleobiological organism. They had to write a paper on some sort of extinct dinosaur. Now, I didn't give them the easy ones. I gave them something really hard. I think I gave them like Odobonosatops, something like that. For the record, Odobonosatops is a dolphin with the face of a walrus. But I went on to Wikipedia the night before, and I just started changing it because I anticipated that I would end up seeing a lot of what I wrote in Wikipedia in the papers the next day. So I just made up a whole bunch of stuff. I said like it had wings and it did all this other things, laid eggs. And what I found the next day was, one, fairly quickly my stupid revisions got taken down, but not fast enough for my students, because the next day I had 6 papers about this egg-laying, flying dolphin. Anybody can change Wikipedia. And I know there are real jerks out there who enjoy doing it, really just to mess with you guys. So, your job as a scientist is to effectively communicate your findings. Publish it, talk about it, do whatever you can. Because if you don't tell people what you studied, nobody's going to know, nobody's going to care. It will go with you to your grave. And then finally, take responsibility for your research. We as scientists do have an awesome responsibility to the world. Your research, no matter what field you go into, can have an impact. And that impact may not always be positive. You need to be able to anticipate what your research can be used for and then decide whether or not you should conduct it or not. Robert Oppenheimer, he was the guy who pioneered the technology to create the nuclear bomb. He created this device and the underlying uses for nuclear power, but he created this device that killed millions of people, or could, and all can, at this point, absolutely destroy the world with mutually assured destruction. But he justified it by saying, the atomic bomb made the prospect of future war unendurable. It's led us up those last few steps to the mountain pass, and beyond there's a different country. You'll notice that since we created the atomic bomb, we haven't had a world war. We're to the point now we're all too scared of each other to have a massive war like that. So he took responsibility. He went to his grave knowing that his device is very dangerous and that he was responsible for the deaths of a lot of people. But he did it, and he took responsibility ultimately. 1988, a little bit closer to now. A team at Bristol University Veterinary School. Their school was the department was underfunded. They would have to cut more than 50% of their staff. Most people would end up losing their jobs. The funding was gone. They had nowhere to go. The government of Britain came in and said, hey, we will fund your entire staff and all of your research projects, which is huge, if only you will study this one bacteria. And the scientists realized that that bacteria had biowarfare potential. So as a group, they said they weren't going to. They decided to take the budget cuts instead. A lot of them lost their jobs and their professions. But at least they didn't help create a weapon. Not only are scientists members of society, but also because of their privileged insight, they have a greater responsibility to ensure that their work is not being abused. Weapons do not make themselves. You've got to keep in mind what your work is going to be used for. You guys are bright. You're smart. And you're going to come up with innovations that can change the world. You want to make sure that the way they change the world is in a good way, not a bad way. Obviously, there are people, scientists who are atrocious, who did not take responsibility for their actions. One is Dr. Josef Mengele. Mengele was a Nazi scientist who was... if you haven't heard about the Nazi experiments, the Nazi human experiments, they were horrendous. Mengele took people who were in concentration camps, the Roma, the Jewish, the homosexuals, and they took them and started doing some research on them. And it was bad research, but they were really trying hard to win this war. The Germans were. They were interested in several different things. One was desalinating water. There were a lot of German planes going down over the British Channel, so by desalinating the water, the German pilots could have water to drink while they were waiting for rescue. That was a major cause of death, dehydration. So they would create new techniques for desalinating water, little pills to drop in the water, things like that. And then they would leave a glass of water in a room with the prisoners. They would not allow those prisoners to have anything to drink, except that water that had whatever chemical they were testing. There were stories that the prisoners would refuse to drink that because it was killing everybody, and instead they would lick the floors after they were freshly mopped to get sustenance. One person survived those experiments. One person out of all of the prisoners in those camps that were involved in it, hundreds of people involved in these, one person survived with massive kidney damage. That one person went on to the Nazi doctor's trial and testified against them. While he was there on the stand, he actually pulled out a knife and tried to kill the doctor who was in front of him. But that's just one example. Another one, they were working on hypothermia. The Germans were fighting on the Russian front. And in case you didn't know, it's a really bad idea to fight Russia in winter. Because, one, Russia's got way more troops than you do. And two, it's cold. Well, the Germans were dying of hypothermia. So what they were experimenting on with the prisoners was cooling their bodies down and then trying to reinvigorate them, to warm them up in such a way that they would save their limbs. So they would put them in ice baths to measure their temperature in different organs as they froze to death. They'd hose them down and throw them outside naked in the freezing cold. They would do all these things and then try to resuscitate them, or try to save just a finger, or try to they'd amputate a frostbitten part and then try to reattach it. These experiments didn't work. Bad science. He got really creepy too. He was really interested in twins. Do you hear about the conjoined twins experiments? So he was very interested in conjoined twins, Siamese twins. So what he tried to do was take normal twins and create Siamese twins out of them, surgically. Crazy stuff. He was interested in creating the perfect Aryan. Blue eyes, taking caustic chemicals and dropping it in their eyes. Totally atrocious. After the war, he got away. He lived in Argentina until the end of his life. Never took responsibility for his research. He always thought he was in the right and always doing what was best for Germany. But it is up to you to take responsibility for your research, which leads me into Don't be evil. Evil is bad. These people are evil. You don't want to be these guys. Dr. Doofenshmirtz never wins, so, whatever. I take it back. If you can ever be Neil Patrick Harris, be Neil Patrick Harris. Aside from that, don't be evil. You want to be good. Scientists. Be like these guys. These are good role models, like Gordon Freeman, Abby, the Doctor, Indiana Jones, Dr. Frick, everybody from Bones except for the guy who was on Buffy the Vampire Slayer. Good scientists. Do we understand the difference between good and evil? Good. That's important to note. Be good, not evil. So there we go. Accurately report your data. Don't introduce personal bias. Effectively communicate your findings, which is not on that list. Take responsibility for your research, and by God, don't be evil. Questions? Now, scientists have a lot of pressure on them. There's a lot of pressure to include bias, to make results go the way that somebody else thinks they should go. You've got this pressure called publish or perish. You may have heard that term before. Publish or perish is something that's really big at research universities. If you're not publishing, if you're not getting out journal article after journal article after journal article, you are no longer hired. You don't get tenure. You don't get to work there. You're not producing anything. So there's this terrible pressure to publish as much as possible. So people they'll fudge the data. They'll make it so that something's significant when it's not, because they want to keep their jobs. Because if they don't have their jobs, they don't get to eat. They don't get to eat, they die. So that's one major pressure. Luckily at DCC we don't have that. At this level in college, they're just like, Chris, just go in there and teach them things. We don't care what you produce. It's like, yes, no papers to publish. I used to have to publish all the time. Paper after paper after paper. But at teaching institutions, usually that's not as big a push. Money. Money's hard. Somebody's got to pay for your experiments, and it's probably not coming out of your pocket, except if you're like at home doing experiments. I guess that's fun. That'll come out of your pocket. But in industry, at universities, somebody has to pay for it. You've got to get money somehow. You can get grants from all sorts of places. Let's say you get a grant from McDonald's to do a study on the nutrition of their food. What do you think is going to come out of that study? What? It would, right. Right. It's probably going to come out that it's not healthy to eat at McDonald's every day. But if you publish that, are they going to give you another grant? No. They'll say, great job doing your sciencey thing. Thanks for the paper. We'll just hold this over here and nobody will see it. They're cool. We don't need your services anymore. And the money dries up. So there's a pressure to give a client or to give a sponsor the data they want to see. And if you don't, they may not come back. So if we can't get money from these private institutions, where do we get... if we can't get money from unbiased sources, the government, NSF funds. There used to be some great funds available. We used to really, in this country, support science. You would get funds to study whatever you wanted to study because there was an idea that the information you were gathering could be used in some way to help everybody. I read an article probably 3 years ago, and somebody was given a grant to study, study pollination in grapes. And they said, here's this grant. They had more than $1 million to study pollination in grapes. And the public was allowed to give commentary on all of these NSF grants. And the public overwhelmingly said, why are you wasting $1 million studying how grapes get pollinated? We could use that money to do other things. Well, what would be the import of studying how grapes are pollinated? That's right! Go straight to wine. California, a lot of California's economy is based on wine. If you can improve the amount that the rate of pollination among those fields, you increase the amount of product, keeping the same amount of money, the same amount of resources going in. It was an economic investment, but people don't see science that way anymore. So all of those grants have dried up. There's no more money. So now where can people go for money? The only places available. Actually, somebody mentioned in the last class crowdfunding. Usually people aren't going to crowdfund a lab. But great idea. Where can people go for money, if not the government? Where? Go to famous people might. They've got some money to spare. Throw it out there. Other places, people who have a vested interest, like McDonald's funding that study, or Exxon's funding studies on how climate change is not caused by man, or Monsanto on how GMOs are just fine, or the Organic Farmers of America saying how GMOs are the worst things ever. There's all sorts of private industries and private organizations out there who will fund experiments provided that the experiments support their already established worldview. And that's where you as a scientist are going to have to walk a really fine line. Because your responsibility is always to the data you get. Politics. Money's dried up, and politics are constantly getting involved in the process of science now. Just recently, and I hate to bring current politics into it, but you've seen a massive purge of scientific thought throughout the government because those scientists didn't support the current view of whoever's in power at the time. And this happens a lot in countries all over the world. As far as politics go, scientists need to be very careful because if they aren't careful about treading on the toes of politicians, they're not going to be allowed to continue their work or allowed to disseminate their work. Politics, how can I put this? As a scientist, your job is to the data. Your responsibility is to the data and your unbiased interpretation. And there are going to be a lot of people who don't appreciate that, and you have to stand your ground. And then fame. Do you guys know who that guy is? Who is that? Right, that's Albert Einstein. Everybody knows who Albert Einstein is. People want to be famous. They want their 15 minutes of fame. They want to be known. Scientists are no exception. And they want to make a major breakthrough. Everybody dreams of winning the Nobel Prize or of discovering this new concept that changes the world. And they've been known to fudge things a little. They want to get out there. Scientists have given into this pressure, but you can't. We want to get scientists to be trusted again, right? The changing perceptions of science and scientists is caused primarily by scientists giving into those pressures. Here's one. This is, I forget his name. But, gosh. I'm sorry. This is the doctor who published a paper showing that autism is caused by vaccines. It was a deeply, deeply flawed paper. The statistics were completely skewed. The big thing is, at the time he wrote this paper, he was acting as an expert witness in a case. And the case was for 13 autistic youth who were suing the vaccine company saying vaccines cause autism. He was acting as an expert witness. He wrote this paper, and coincidentally, this paper showed in 13 cases, people who have had vaccines also developed autism, thus there's a link. Well, it wasn't randomly drawn. It was these people that were involved in the case. He got paid $200,000 personally to be an expert witness in that case and to help prove that point. There's a lot going on as far as giving into pressure there. Turns out, later, he was completely discredited. Utterly discredited. Pulled his medical license. The paper was retracted. Everything. And there have been hundreds of, actually probably thousands at this point, journal articles now showing there is no link between autism and vaccines. Yet, I guarantee some of you guys know people who will not vaccinate their children. They'd rather say, yeah, my kid will be fine with mumps, rubella, measles, smallpox. These are all making a resurgence now in the United States because of that guy. That being said, back to Mark Twain. Easier to fool people than convince them they have been fooled. Here's another fun one. This gentleman, he is a Chinese scientist who claimed to have cloned the first human being. We've cloned sheep, we've cloned dogs. In case you didn't know, if your dog dies, you can now take its carcass and clone a new one. Surprise. Now he's saying we can clone people. He produced this data and said, look, I have an announcement, I've cloned the first human. Here's my data. People looked at it and was like, holy cow. There's actually a moratorium on that. You're not allowed to look into human cloning. But he looked at that. He cloned, said he cloned the first human. Said there'd be a press conference later. He produced a baby and said, "This is baby Eve," because that's the way it works. Turns out, the baby wasn't a clone. In fact, he lied about his data. He'd been working for so long to try and figure it out that he just gave up and made up the results. He's in jail now, not just for fraud, but for the fairly unique crime of misuse of human embryos. So if you go to jail, go in with that one. Misuse of human embryos. Nobody will mess with you. You're like, what you in for? Murder? Yeah. Misuse of human embryos. There we go. These scientists have changed the perceptions. Oh, this is another fun one. Do emails reveal scientists' claims on climate change are bunk? There was this thing, it was called ClimateGate a while back. Somebody hacked into the email server that was going back and forth between Oxford and UVA, so Virginia. And they were talking back and forth about climate change. And in one out of these 43,000 emails, a scientist said, I know a statistical trick we can use to interpret this data. And the people who were reading it said, he said trick. They're lying to us. Our Attorney General at the time, Ken Cuccinelli, thought there was so much into this that he went to UVA and said, you have to give back the $200,000 grant that the state gave you because you're trying to trick us. And I don't know if you guys know about UVA, but they've got their own law school, so they've got some pretty good lawyers. And the lawyers there said, yeah, no, we're not giving it back. And you're wrong. So the Attorney General went and spent roughly $800 to $1 million of the state's funds based on labor and expenses to sue UVA to recover $200,000 because he wanted to make a point. He lost. But it's still, because it was everywhere, because it was in the media, it still discredited science. So you got to be careful. So there we go. It's going to be up to you guys to advance the global well-being with your research. It's going to be up to you to accurately and unbiased way interpret your data so that the rest of us can learn from it. Because the people who came before you as scientists screwed it all up. Our goal now is to, I'm not saying we have to be #1 in Reader's Digest, but I'd at least like to be above the police. That's all I'm saying. Just like 2 steps up. That's all I want. And that's going to be up to you. So I just want to give you a brief idea of my interpretation of the flow of science. So it's this idea that biology does not exist in a void. It exists in relation to all the other sciences. First off, I want to just say metaphysics, the uncaused cause, those things we can't measure. Something happened, and we don't know what it is right now, but that led to physics. Physics, if you understand all of physics, all of the ways particles and waves interact with each other, if you understand all of physics, you necessarily understand all of chemistry. Because all chemistry is subatomic particles getting together to make larger molecules. And if you understand all of chemistry, you're going to understand all of biology, because what's biology if it's not a bunch of chemicals that got together and thought they were alive? And if you understand all of biology, from there, you build into all the social sciences. Psychology, sociology. Because what is psychology if it's not all of these things that are living and thinking that they're alive, starting to interact and grow, leading to sociology? They get together in groups. And then sociology would lead into history. Because what's history if it's not the sociology through time? I stole that from Miss Taylor. Last concept, absolute last concept. What is life? That's the question. That's that interactive part. What is life? To help you out, I have a brick. This is a brick. I think we can all agree this brick is not alive. Right? We're good on that? You are alive. We can all agree on that. What is the difference between you and a brick? And it's really sad that you don't have something off the top of your head right now. You breathe. You take in, you metabolize products. You pull in oxygen, you release carbon dioxide. That's one. Good. What else? You can move on your own. You can respond to your environment. If you're in a fire, you will leave the fire. If the brick is in the fire, it will stay there. What else? React to external stimuli. I guess that's what that would be called. Intelligence? Well, there's some things that are alive. And you know people that you can't really... people, yeah, I mean, I've taught them. I mean, it's... Intelligence doesn't indicate life, but what else might indicate life? Yeah. What? Awareness. If it knows what's going on around it, I can see that. Being able to respond to its environment. That's big, too. Adapting to the environment, changing from one generation to the next, biological evolution. Yeah, that's good. In order to do that, in order for that to happen, because you can't change yourself, you're going to end up, your offspring will be different. What do you need then? Reproduction. I mean, this brick, I guess you could split it in half, but that's not real reproduction, not like you do. You maintain a consistent internal environment. You got that whole 98.6 degree Fahrenheit thing going on. The brick, not so much. Granted, there are some cold-blooded things that can't do that, but they still will regulate their internal environment. That's called homeostasis. Anything else? Any other ways you and a brick are different? It's sad when you think about it, and you're like, oh, there's only like 6 or 7 ways I'm different from a brick. You can what? You eat things, you metabolize things, that's good. So here's what I came up with. You've got some distinct organization to your body. Brick, not so much. I mean, the brick does have these 3 holes on top. That's about it. But you've got cells that can come together to form tissues, that can form organs, that can form systems, that can form you. You use energy and metabolism. We hit that a lot. You breathe in, you breathe out. You eat things, you excrete things. You respond to the environment. If you're on fire, you'll put the fire out. The brick won't. Homeostasis, you maintain that internal consistent environment. You grow and develop. Over time, you become something new. Developmental psychology, there you go. Reproduction, you can have offspring, and those offspring might be different from you, leading to differences in survivability, and that leads to biological evolution. So these are sort of the traits that all living things have in common. So when it comes down to it, all you need to do is think of, how am I different from a brick? And if you can come up with a few answers, you're good. And if you can't come up with a few answers, there are issues. Any questions? All right. I think that's about all I have. I do want to point this out now. A previous student of mine, Jamie Butcher, who actually just finished the nursing program, said that biology is like building a house. The first 2 weeks, so from here shortly, are like building a foundation. You need a solid foundation. You need to understand this material cold. If you don't have the foundation, if you just memorize something, if you don't learn it, because there's a difference between memorization and learning. If you don't learn it, you're not going to have a strong foundation and everything else falls apart. You'll find very quick, she said at this point where we're building on, if you don't get the first few weeks, you're pretty much doomed. If you're trying to memorize your way through the class, I will tell you right now, it's going to get harder and harder and harder and harder. Everything in biology connects to everything else. If you can find the connections and hold on to those connections, you win. It will become easier. There will come a point in the class where all of a sudden, I stop teaching you new concepts, and all of the other concepts that I had taught you just get restrung together in new ways. But if you memorize your way through, it's just going to be constant memorization. Now, at the end of all lectures, I have these things called content review questions. These are not, I just want to be very clear, these are not the exam questions. But these are the most important concepts I think are in the lecture. These are the things that I really want you to understand. I need you to be able to understand the responsibilities of the scientist. So you need to tell me about not introducing bias. You need to be able to tell me about accurately communicating your findings. Accurately recording your results, communicating your findings, and taking responsibility for your research. What's the difference between science and pseudoscience? What is science? Testable. And then what are some characteristics of living organisms? How are you different from a brick? Those are probably, to me, the most important things I'm drawing out of this lecture. So all of the lectures will have that in the future. I would use it as one of the things you use to study for the exam by. I will not give you a review sheet or anything like that, but that's what I consider to be the most important thing here. Concerns?